Bore da, croeso I Gogledd Cymru, neu ddechrau'n Gymraeg, dwi'n meddwl, croeso I Gogledd Cymru, a dwi'n yn siŵr os na fi ddylai fod y person sydd yn croesawu bobl yma I Ogledd Cymru. Mae Martin wedi wneud o gyna, dwi'n meddwl, ond gan bod fi'n dod o Ogledd Cymru, dwi am gymryd y cyfle I groesawu pawb yma, achos dwi'n byw lawr lôn, a mae'n handi iawn I fi fod yn trafeilio yma bob dydd. What I said in Welsh then is that I'm going to do this whole presentation in Welsh. No, that's not it. Was to welcome people, actually, to North Wales. I'm not sure if I should be the one that does welcome you to North Wales, but I'm definitely going to do that because I live just down the road in a place called Molvra, just on Anglesey, and I've lived there for all of my life, apart from the time I went to university in England. I work for Minesto, and my name is Osian Roberts, and I'm a business development manager for Minesto. I'll talk to you a little bit about what we've been doing. There's certainly some people here that know who Minesto are, but from my conversation with people this morning, there are certainly some people that don't know who Minesto are in this conference. So we'll go right back from the sort of introductory piece to where we're going and the exciting things that have been happening in the middle. So Minesto, founded 2007, spin-off from the Saab group in Gothenburg in Sweden, and we do have a considerable amount of employees to date. I think it's a little bit more than 60 now, but we'll say 60, and they are based between our sort of sites or operational sites in Sweden, in the UK, which is Northern Ireland and Wales, Taiwan, and in the Faroe Islands. We've also invested a considerable amount of funding into developing our sort of award-winning deep green technology to date, and that figure, I think, is around about 115 million euros. And one of the key sort of highlights for me over the last couple of years, the key successes is when we were able to deliver electricity to the grid with a first commercial scale unit towards the end of 2020. We are listed on the Nasdaq First North in Stockholm, and there are two other main owners listed on the last bullet point there on your slide, on this slide. So what do we do, and sort of what is this investment highlighted or been directed towards? You know, we have this game-changing renewable energy technology called deep green. It's patented, highly patented, of course, and it's the only verified technology that can exploit energy from low to medium flow or from low and medium flow tidal stream scenarios. There's definitely an attractive commercial offer in that the energy we produce is from the tides, and it's plannable, it's predictable, and we can do that in a very cost-effective manner. And all these things together open up a so far untapped area within our industry, in that we can access up to sort of 600 gigawatts plus of potential capacity, which far exceeds that of the current nuclear capacity of the world. We've also been very busy expanding project pipelines, as we put it, collaborations with utilities, some electricity customers, and with other industrial partners over the last year or two. Again, some of you have seen this animation, maybe with the older iteration of the kite, actually, but this shows how our principle works, or how our device works. It's tethered to the seabed, and you imagine flying a stunt kite as you did when you were a child. And what we do is use our a wing we drive a wing through the water, and effectively, because we then strap a turbine to the underside of that wing, we're able to force water through that turbine faster than the relative speed of the tide in the first place, creating that ability to draw energy from those low flow scenarios. And why do we do this in water rather than air? Well, clearly, you know, water is far denser than air, and its sort of kinetic energy is therefore, or the kinetic energy held within is therefore much greater as well. And putting all this together, you know, it gives us a device and a way to cost effectively exploit that so far untapped energy resource. I'm not sure if there's much of a need for me to sort of talk about this, but we all know why we're here. The market drivers are absolutely clear, and they've been no more pronounced than they are sort of today and in the sort of last few weeks during the sort of, I was going to say situation, but somebody told me to say the war in the Ukraine, so I will say the war in the Ukraine. And that leads us to that need for a balanced energy mix. And I think Tidal Stream and Minesto's products particularly can significantly contribute to providing that secure and plannable energy mix and take us to that sort of net zero goal that we all talk about. Enter the dragons, it says. I wish I'd have coined that term myself, but unfortunately I can't claim to have coined that. That was actually Martin, our CEO, in a presentation in Southampton towards the end of last year, but I'm going to steal it for today. So this, some of you may have not seen this, but this is a short introduction to our new kite design. There's a model actually on our exhibition just downstairs, and we do term these now the new Dragon class designs for Minesto. And we've taken all that learning from the last sort of few years and brought forward into something that the principle is exactly the same, but the actual design is quite different, you know, and is there to sort of maximize the yield and minimize the costs of what we produce. And we've taken away the struts. Some of you might remember the struts, and essentially that's to do with lessening drag. We've also moved the sort of turbine to the rear of the device, which then gives the wing a sort of clear and uninterrupted access to the tidal flow, to that resource. It can be tailored in any way, different wing spans, different tether lengths, different generator sizes, to be optimized to a given situation for a given customer in any given context. And of course they are very scalable, and from anywhere from sort of 50 kilowatts to sort of showcase piece of 1.2 megawatts kite design. Whales. Let's talk say something about whales. I think, you know, when I first came to Minesto, we were talking a lot about demonstrations, but as the industries move forward, and as we've moved forward as Minesto as well, we talk very much about sort of commercialization now, and it's exactly where we want to go. We want to be on that sort of cusp of commercialization. And, you know, Holyhead Deep, we've been there since 2016, testing in 2018 onwards, and it sits there very much then and still now at the forefront of Minesto's commercial plans. You know, we have this really strong asset base there. Not many of you have been to our assembly hall. A couple of guys from Marine Energy Wales have been there. We're going to open it up in an inauguration ceremony towards the end of the summer. But it really is there. You know, it's a firmly established manufacturing, assembly and testing facility. And the group of guys that work there really are, you know, extremely specialist and, you know, highly skilled. And then the only sort of team in the world that understand how to deploy and understand how to commission and understand how to operate Minesto's deep green technology in any site across the world. And that's a huge asset to have in Wales. It's there to be developed, and it's there to be as an export offer, which we all talk about in this industry. So exporting something from Wales really is fantastic to the world, and bringing those benefits back is something that should not be underappreciated. It's worth also me showing this next video, because whatever we do, it contributes to wherever we're going to go in the future. And this is our site in the Faroe Islands, and it just shows a little bit of what we've been doing around the installation of our devices there. And we've taken the learning from the Faroe Islands to bring about the new design that will then go into our commercially ready sites in North Wales, and again in a place called Hestfjord, also in the Faroe Islands. And it is where we will now continue to test the Dragon class designs to generate long-term performance, data for those commercially ready sites to bring about that sort of inbound investments. Expanding project portfolio. We've talked, well I have at least, around a couple of the sites, the Faroe Islands. Indeed, we know what that means for Minesto. We know what the site in Holyhead means for Minesto and what that means for Wales. And that it does have that sort of ability to act as the sort of factory in testing facility and assembly to take those devices then to the active sites across the world. But it's worth mentioning France as well, where we continue to collaborate with our colleagues in EDF, and also in Asia and North America, where we not only try and develop sites or are actively developing sites for tidal stream, but also for ocean current, in ocean current contexts. We've touched upon the team. I will continue to touch upon the team because it's really important that you have a sort of great team around. I'm not going to run through the whole slide, but it's important for me to sort of reiterate the sort of caliber of individuals that we work with and how well that works as a team. And, you know, we're all aligned behind this sort of common goal and working together to drive the success that we foresee for Deep Green in the future. So it's really important to continue to say that. I'm getting told I've got 2 minutes left. This is my last slide, Jay, so you'll be happy with that. And in order to continue to drive that success, there are 3 key areas that we're looking at. You know, we want to sort of deliver on existing projects and our commitments to our existing partners and customers. We want to scale those up. I talked about 1.2 megawatt devices. We've talked about expanding on those sites, starting with 10 megawatt pipeline arrays, which are very much something that we are working on quite hard right now. And then that further site capacity build out to expand then further into other sites across the world and strengthen industrial collaborations with key partners. And bringing all that together, you know, we want to deliver industry-ready commercial projects and contribute to achieving net zero targets. And the last thing I will say is what we've been saying for the last few years is that really now we believe that this industry, and I'm talking tidal streams specifically, can be the new coal industry for Wales, with the significant difference being the resource we draw upon can last forever. Diolch.
So I'm going to give you an update of where we've been over the last couple of years with the marine power systems. It's been a really busy and exciting time for us. Lots has happened. So I'm going to bring you all up to speed with it right now. So at Marine Power Systems, we're developing 2 fundamental pieces of technology. The first one is the PELAGEN wave energy converter, and the second one is the PELAFLEX floating platform. Now, these 2 pieces of technology can then be brought together by our customers as either floating wind only, floating wave only, or a combination of the 2 in a single device. And we anticipate that to be combined in a farm context as well, so different combinations of devices within a farm. The goal of that is to fundamentally improve the yield per kilometre squared, to improve the levelized cost of energy, and to improve the consistency of supply. So wave energy is, you know, depending on latitude, it can be basically a completely separate energy source. So really important as the amount of wind on the grid increases, different energy sources, improving the energy mix. I've just noticed that the font isn't installed on Jay's computer, so apologies for some of that, but that's a font issue. Okay, the next thing is just a little bit more detail on our PELAGEN wave energy converter. So it's a very efficient device. It harnesses both heave and surge energy. It aligns itself to the direction of the waves. It tunes itself to the ongoing sea state. And importantly, only the absorber contacts the sea. So the power generating equipment, all this sensitive stuff, that's all in the nacelle that stays above sea level the entire time. PELAGEN has got lots of advantages. I'm not going to read through the slide. What I will say, though, is that through the evolutionary process that we've been working on at MPS, we found that the device has now got a lot of synergies with with wind turbines, and we think that's a really good thing. There's been no intention to do that. It's just how we've best met the requirements. So we have a separate nacelle with the generators, gearboxes, control electronics, and then we have the absorber, which is analogous to the blades, which is essentially a large, lightweight structure that captures the energy. And we see that that's a really important benefit to our technology, that synergy with wind turbines. It's good economically, but it's also good from a perception point of view. People understand how that works, and we see that improving the transition into the marketplace for this technology. Our Pelaflex floating wind platform, again, a lot of work's gone into this. It's a very optimal piece of technology. It's structurally efficient, pure tetrahedron. It's got a low material content. It's very stable in use. It's got good floating performance as well. And it's also, we've paid an awful lot of attention to the manufacturing and supply chain. And and further to that, installation and hookup is also enabled by a safe, rapid hookup method. Again, I'm not going to read through this slide, but the important thing to take away here is that we've considered the technology right from the outset, from having to engineer for a project site with our customers through the entire life cycle of the technology right through to end of life, and how to decommission and recycle the technology when the project is over. So this technology is going to be demonstrated at multi-megawatt scale at BIMEP. The device will be in the water in 2023, at summer 2023. There'll be 2 megawatts of wind turbine, 0.5 megawatt of wave energy, and that project is going really well at the moment. I'm sure some of you will have seen our invitations to tender going out on LinkedIn, so you can all see that that project is happening at a pace, and we're all really looking forward to getting that in the water. A little bit more now about the Pelaflex floating platform. I'm just going to share a little bit of information about a concept study that we've done. This is a hypothetical device for the Celtic Sea. We've chosen a water depth of 70 meters. It's a 15 megawatt MREL turbine, but it's been a very positive study. The platform has around 200 tons of structural steel per megawatt. That's a very competitive figure. Just a little bit of data about the draft and height. So about 26 meters installed draft. The tower height is, this depends on the turbine selected. And at quayside, one important advantage of our technology is the very low floating draft. So when we heard earlier from the Minister around investment needed in port facilities, not having to make deep water ports is very beneficial to the level of investment that's needed to get this industry happening in Wales. This is just an excerpt from Orcaflex. The platform performs very well installed. It's very stable. The acceleration is less than 5 meters per second. This is a 50-year storm part condition, so pretty much the worst conditions we can expect. The maximum offset is around 20 meters, and the maximum tilt is 2 degrees. So these are very, very competitive figures and absolutely what's needed, especially considering the Celtic Sea is quite shallow. It's thought of as quite a difficult site to achieve these good numbers. Further to this, we've also developed an advanced mooring layout. It's not shown here, but this further improves those metrics. So, less than 2 meters per second squared acceleration, and next to no offset, less than a meter, and almost no tilt, less than a degree. So this is something we can work with developers if they're interested to, really maximize turbine compatibility, minimize wear and tear on the turbines. The floating performance is important as well. So it's absolutely vital that projects can be delivered with maximum weather windows. What we don't want is projects waiting for turbines to be installed, so it's really important that we can tow the turbines around in wide weather windows. This video just shows what happens in a 3-meter sea state with a 10-second headwind towing at 5 knots. And the whole idea is that this is a really boring video because no one wants to see anything exciting when you're trying to tow your device out to site. Another place that we've put a lot of work into is the manufacturing and assembly philosophy. A little bit text heavy, but we've really, I think the takeaway from this is that we feel that at MPS, we've really created an optimal pathway from raw steel through to kit in the water, and that whether that's the component fabrication, the assembly, and the loadout and launch, we really work hard to make sure that all of those things are as streamlined and as efficient as they can be. So a little bit more on the component fabrication. I think the main takeaway here is that we're starting off with a small number of primary steel components, and not only a small number of components, but there's only 4 individual components there. So suppliers can get really good at making these parts and just make lots of them. We can distribute this into the supply chain. We can use the existing supply chain, the corner nodes and the transition piece will fit into the factory fabrication supply chain that's busy as we speak, making jackets and transition pieces for fixed wind. And the braces will fit into the wind turbine tower supply chain, which as we speak are busy making wind turbine towers which are of the same kind of size and scale and complexity. And we think this is really important to optimize costs, open up a wide supply chain, allow UK and local suppliers to easily invest and expand their capabilities, and just generally make sure that this can actually happen and not be limited by the availability of shipbuilding facilities and dry docks and that type of thing. The assembly, as I mentioned, a lot of work's gone into this to make sure it can happen quickly without a huge amount of specialist equipment at yard. So as you can see there, picture tells 1,000 words, so I won't say 1,000 words and I'll just direct you to the pictures. It's all straightforward. The effort's going into making sure that this is safe, that this work can carry on in all weathers. We can build up a stock and wet store them over the winter for deployment and integration over the summer. And again, we anticipate at sort of gigawatt scale being able to launch devices at the rate of more than 1 a week. And the same slide about the multi-megawatt demonstrator project, which I won't go through again. So the last slide is the MEC pre-commercial project. So as I mentioned, we're demonstrating the combined wind and wave technology at BIMEP. We also have a project booked at EMEC. So we're working on that now. We're in the pre-feed stage. The berths are booked. We've conducted seabed surveys, and we expect to be in the water in 2025 with that project. So another really exciting development for MPS. Certification is something, of course, that's really important to us. The project developers want to know that they can get insurance and the technology is going to be reliable. So we'll have a statement of feasibility for our floating platform in Q2 this year. So that's all going really well. And then this slide just gives an overview of the certification process. So we could support a project deployment as early as 2026. Most projects are a little bit behind that, but we're in exactly the right place with our Pelaflex platform technology to meet customer expectations. So there we are. Thank you very much, everyone. I'd like to thank our funders, Department of Business, Energy and Environment and Industrial Strategy, Innovate UK, and WEFO, so thank you to them. And I think time-wise, I know Jay said there's no questions, but if we've got time, I am happy to take a couple of questions. Thank you.